Alrighty, welcome back from the other video. What we're going to talk about today, polynomials, linear factors, and zeros. So let's just start with the word zeros. So zeros are x-intercepts, roots, or solutions. So if you hear me say one word, and then another time I'm saying the same exact thing, but I use another word, it's because zeros, that's all the same thing. So, in the last video I said we're going to talk about factoring the polynomials and then how we were going to decide what to do in between our endpoints. So we're actually going to save the factoring for next week, but this week we're just going to have it so they give it to us in a factored form. So for example, I have 0 equals x to the x plus 3 times x minus 5. So what we're going to have to do is solve for our zeros or find our x-intercepts. So what we can do is we're just going to set each of these x's to 0. So the first one's easy. I just have x equals 0, x plus 3 equals 0, and x minus 5 equals 0. So the nice thing is x equals 0 is already solved, and then I just have to solve these other two. So we have x equals negative 3, and here we're going to have 5, so I know it's x equals 5. So these 3 are my x-intercepts. So if I drew a graph here, 1, 2, 3, 4, 1, 2, 3, 4, 5. I could go ahead and draw my little dots. So I have an x-intercept there at 0, 1 at negative 3, and an x-intercept at positive 5. So, cool. We know our x-intercepts. But you're thinking, okay, well, how do I find what it looks like? Which way does the end go? So that we can actually look at this. We can look here at our already factored form. So the first thing I want to do is find my degrees. So if I multiplied everything together, folded out, I would have x times x times x. So x times x is x squared times x is x to the third. So I would have x to the third. So I know that my degree is equal to 3. So since we know our degree, we can find out how many turning points we have. So in the last video, we said the number of turning points is equal to the degree minus 1. So 3 minus 1 is 2. And then the last thing we want to know is our end behavior. So this is probably the hardest part, is remembering how to find our end behavior. So from the last video, we were talking about if it's an odd number, we know it's going to either be down up or up down. And then from there, we have to see if it is a negative number or not. But if I look here, I have a positive x, and another positive x. So since those are all positive numbers, I know that this is going to be a positive. So positive x to the third is going to give me this down, up end behavior. So when we get to our graph, this is just a sketch. It's not an exact science. We just want to get an idea. So I know that based off of our little info over here, so my end behavior was down, up, and then going to go through. So like this, like that. So that's my sketch. So I can look. I have two turning points. One here, and there's my second one. I have my x-intercepts at 0, -3, and +5. And my end behavior is down, up. So you're thinking, okay, what about, how do we know if it actually crosses through or if it just kind of bounces off those x-intercepts? So that's where we get to multiplicity. And all multiplicity is the number of the same answer. So if it is an odd number, it's going to go through. So like here we have 0, -3, and 5. None of those numbers are repeated, so it just goes straight through. If it's an even number, it's going to bump and run. So for this, it's going to go up, it's going to touch it, and it's going to turn right around. So if I had x equals 7, 7, and 3, these two 7s, it's gonna bump and run at 7, and then it's gonna go through at 3. So next video we will go over an example of that where we have an even number.